Hi class, Norman Stevens here, your friendly economics teacher. I'd like to go over the checkpoint questions in Chapter 5. Typically in the on-ground class, we would first look at the problems and solve them in groups or individually in class, and then present the answers to the class and determine the methods on how to best solve the problems. So you might want to first try these problems on your own and then check my answers. Here we go. The first question states the following. Figure 5.1 shows the flows of income and expenditure in an economy. In 2009, U was 2 trillion, V was 1.5 trillion, W was 7 trillion, X was 1.5 trillion, and Z was 0. Calculate total income, net taxes, and GDP. I've reprinted the image here of that flow. You may wonder why the question uses different algebraic letters of Q and R and U instead of giving the original formula and designations, which I've reprinted here, which shows Y, S, N, T, and G to represent the different parts of the GDP calculation. The reason why the textbook uses these new letters is that it's attempting to find out, can you really identify how to solve for GDP or net taxes? Can you determine these amounts without having the original letter designations? And sure you can. So like I said, I reprinted this from Chapter 5 in the textbooks. That's what the original circular flow looks like. You're going to substitute then some of the different letters to figure out the total income. Total income, which is flow Q, equals total expenditure. That's the sum of consumption expenditure, investment, government expenditure on goods and services, and net export of goods and services. Flow U is government expenditure on goods and services, G. Flow W is consumption expenditure, which we originally use as C. Flow X is investment, or I. And flow Z is net exports of goods and services, known as NX. So the total expenditure formula reads Y equals C plus I plus G plus NX. Then you substitute the letters into the original formula. That is, these new letters you're given in this new chart, and simply put in those numbers. And you'll get 7 trillion plus 1.5 trillion plus 2 trillion plus 0, the total comes out to 10.5 trillion. Net taxes, those equal the total income minus consumption, expenditure, and saving. So we know that total income is 10.5 trillion. Consumption expenditure is 7 trillion. Saving is the flow into the financial markets, that's flow V, and equals 1.5 trillion. So net taxes equals 1.5 trillion minus 7 trillion minus 1.5 trillion, which is $2 trillion. Total income equals total expenditure, which equals GDP. So GDP equals 10.5 trillion. Next question states, use the following information to work problem 2 and problem 3. The national accounts of Parchment Paradise are kept on, you guessed it, parchment. A fire destroys the statistics office. The accounts are now incomplete, but they contain the following data. GDP, using the income approach, of $2,900. Consumption expenditure, $2,000. Indirect taxes, less subsidies, of $100. Interest, rent, and profit, $500. Investment, $800. Government expenditure, $400. Wages, $2,000. Net factor income from abroad, $50. And net exports, $200. Question 2 states to calculate GDP using the expenditure approach and depreciation. For the expenditure approach, GDP equals the sum of consumption expenditure, investment, government expenditure on goods and services, and net exports. Unfortunately, these data were saved from the fire. So, we know the standard GDP formula, GDP, also known as Y, but GDP equals C plus I plus G plus NX. So you can substitute those numbers, add them together, and you'll get $3,000. From the income approach, GDP equals the sum of wages plus interest and profits plus indirect taxes less subsidies plus depreciation. The value of the income approach, GDP, survived the fire and is $2,900. The sum of wages plus interest, rent, and profit plus indirect taxes less subsidies equals $2,000 plus $500 plus $100, bringing a net total of $2,600. So depreciation is going to equal $2,900 minus $2,600, or $300. Question 3. Calculate net domestic product at factor cost, the statistical discrepancy, and GNP. Net domestic product factor at cost equals the sum of wages, interest, rent, and profit. And once again, all these data were fortunately saved from the fire, so net domestic product at factor cost equals $2,000 plus $500, equaling $2,500. The statistical discrepancy equals GDP from the expenditure approach, $3,000 from problem 2, minus GDP from the income approach, which is $2,900. So the statistical discrepancy is $3,000 minus $2,900, or $100. GNP equals GDP plus net factor income from abroad. From problem 2, we know that GDP is $3,000. Net factor income from abroad is $50. So GNP equals $3,000 plus $50, or $3,050. Textbook states to use the following information to work problems 4 and 6. An economy produces only fun and food. The table shows the prices and the quantities of fun and food produced in 2009 and 2010. The base here is 2009. Question 4 states, calculate nominal GDP in 2009 and 2010. Nominal GDP in 2009 is equal to the 40 units of fun times $2 plus 60 units of food times $3, equaling $260. Nominal GDP in 2010 is equal to 35 units of fun times $3 plus 65 units of food times $2, equaling $235. And it states to calculate the percentage increase in production in 2010. The percentage increase in production is equal to the percentage increase in real GDP. In the base year, real GDP equals nominal GDP. So real GDP in 2009 is $260. Then using prices from 2009, real GDP in 2009 is $260, and real GDP in 2010 is $265. Using 2009 prices, real GDP grew, and using the formula of 265 minus 260 divided by the original number of 260 times 100, or 1.9%. So there's the percentage change. Question 6, if potential GDP was $270 in 2009 and it grew by 1% in 2010, in which phase of the business cycle is the economy? Explain. Well, between 2009 and 2010, real GDP grew, so the economy is in the expansion phase of the business cycle. Use the following information to work problems 7 to 9. Higher prices pushed up consumer spending for June. The Commerce Department reported that retail sales increased 0.8% in June, but net exports fell 0.3% in the second quarter of 2009, and inventories held by businesses fell by 1.1% in June, while sales at all level of production were up by 0.9%. The source is the Commerce Department, August 13, 2009. Question 7 states, which component of GDP changed because retail sales increased? Which component of GDP changed because inventories held by businesses fell? The increase in retail sales means that consumption expenditure on goods and services increased. The decrease in inventories held by businesses means that investment decreased. So consumption went up, investment went down. Question 8, explain the effect of the fall in net exports on GDP. Because net exports is part of GDP, the fall in net exports means that GDP decreases. Question 9, does the statement that sales at all levels of production were up 0.9% mean that GDP increased by 0.9%? Explain your answer. Well, the statement that all levels of production were up 0.9%, that's obscure. If sales of all levels of production includes final goods and the intermediate goods, then GDP is not up 0.9%. In this case, GDP is up by less than 0.9% because some components of GDP, such as investment and net exports, fell. I hope that's helpful. Please let me know if any of the questions or answers are unclear, and hope to see you in class.